Welcome to another secondary snack. My name's Christina Turner and I'm a lead maths specialist for White Rose Maths. So today we're going to be looking at the block, ratio and proportion in year 9. So here are the small steps for ratio and proportion, and we're going to be focusing on the review steps, solve problems with direct proportion and conversion graphs. So we're going to be having a look at how we can get the most out of these two review steps. So here's the notes and guidance section for the first review step, direct proportion. And if we have a look at the exemplar questions, you can see that we start with a question where students have to work out missing values and they're giving a table to support their thinking. Whereas in the second exemplar question, they're given a double number line to support their thinking before finally looking at something that's more abstract. So here they're using an equation to work out missing values. So we're going to start by having a look at this exemplar question, and we're going to use it to answer some of these key questions. So here's that exemplar question again, and we're going to start by thinking about how we can really get the most out of this question with the students. So perhaps we just start with a general discussion. First of all, emphasising what happens for zero quantities. So if I paid £0, how many bags have I bought? So really emphasising the idea that when variables are in direct proportion to each other, if one of the variables is 0, then the other must be 0 as well. And then moving on to discussing where the students might start. So is there just one starting point in that question? Do they have to start with working out the cost of 2 bags, or perhaps they could start by working out the cost of 8 bags? So really promoting that flexibility of approach. And maybe asking students what else they can add. So can they work out the cost of 80 bags or 22 bags, for instance? And finally, really making sure that we use the questions to define this idea of variables that are in direct proportion to each other. Or perhaps you might not use the exemplar question in that way to begin with. Perhaps you just give the students the key information. So 4 bags of sweets cost £3.20, and just ask the students what they know and what they can find out. And it'd be really interesting to see how they go about that question, what kind of jottings they use to support their thinking. So perhaps they start with a double number line and use that to work out other values. Here's the double number line for that question fully completed. So how might we use this further to really deepen that understanding of variables that are in direct proportion to each other? Well, perhaps we start looking at those key relationships. So here you can see that to work out 2 bags, well, what mathematical calculation, what did the students actually do to do that? So this idea that actually we've divided by 2 or multiplied by a half, so we know that 2 bags cost £1.60. And if we wanted to find out the cost of 8 bags, well, we can see there that we've multiplied by 2. Perhaps asking a question such as how much will 7 bags cost will really help deepen understanding further. So maybe we look at dividing the cost of 2 bags to get the cost of 1 bag. So 1 bag costs 80p, and then the idea that we multiply that by 7 to get the cost of 7 bags. Or perhaps more efficiently, we just start with the information we were given. So the idea that we've got 4 bags is £3.20, and we can just divide by 4 to get the cost of 1 bag, which is 80p, and then multiply by 7 to get the cost of 7 bags. What we're trying to do is show the students those multiplicative relationships. We want them to really be able to visualize those and to be able to see them, and that's what the double number line does. For some students, they get stuck around additive thinking. So the idea that if 1 bag costs 80p, then I need to add that together 7 times in order to get the total cost. So the power of using things like the double number line is definitely that it allows students to see these multiplicative relationships, and it helps to move on their thinking. And we can explore relationships further. So here's the double number line again, and the question, how much will 7 bags cost? And perhaps students notice that to find the cost of 2 bags, we can just multiply by 80p. the same for 4 bags, so we can do the same for 7 bags. And again, we're showing the students the multiplicative thinking to help them move away from the additive thinking. So where might we take this next? Well, perhaps we link it to ratio. So the idea that for every 4 bags, it costs £3.20, and every 8 bags, it costs £6.40. And then look at the relationships between these numbers. It's very clear in this way, I think. So we can see the multiplier of 2 and the multiplier of 80p. And with your students, you might want to look at relationships, multiplicative relationships that are more difficult to spot. So perhaps looking at what's a multiplicative relationship between 4 and 6. Okay, and finally, on the theme of bags of sweets and cost, perhaps we really explore that idea of flexibility of approach to these kind of questions and ask the students something like this. So how many different ways can you find to work out the cost of 4 bags of sweets? So you might want to pause the video now and just think about how you might do that. Here are some solutions from students. So starting with the fact that 14 bags cost £4.20, and then halving this to get the cost of 7 bags. A lot of students like halving. And then at that point, perhaps they go directly to the cost of 1 bag of sweets and then multiply that by 4 to get the cost of 4 bags. Or maybe they started by dividing by 7 to get the cost of 2 bags and then multiplying that by 2 to get the cost of 4 bags. Or maybe they started by dividing by 14 to get the cost of 1 bag and then multiplying by 4 to get the costs of 4 bags. Perhaps they doubled £4.20 and then divided by 7. There's so many different ways of doing this question. And what's really important is to explore those different methods with the students, to talk about them in the classroom, to model them, and then perhaps to ask the students which strategy they prefer and why, and maybe which one they think is the most efficient. And it's really interesting with students, I think, to explore inefficiency sometimes, because that really helps them to understand which is the most efficient method. We could then start looking at variables that are in direct proportion to each other that are in a different context. So here we're looking at map scales. So 4 centimetres on a map represents 3.2 kilometres on the ground. And perhaps we also look at a different representation. So here we're looking at this information on a graph. So perhaps we pose the question, what would we label the x-axis and the y-axis? So centimetres on the map, kilometres on the ground. And we can use this to remind students how to construct the conversion graph and also how to use it. Here's another question. An insect travels at a constant speed of 3.2 metres every 4 minutes. Assume the insect always travels at the same speed. And then ask the question, do we need to change the graph? Can we use the same graph, or do we need to change the line or the numbers? How would that work? And actually, the fact that we can use exactly the same graph, but we just need to change the labels on the X and Y axis. And another one, perhaps we look at conversions of money. So $4 is equal to 3.2 euros. And again, can we use the same graph? How would we label the axes? And it's really powerful to show the students that, because they get the idea that even though there are different contexts, it's the same mathematical structure and the same mathematical thinking. And finally, perhaps we go back to our bags of sweets. So 4 bags of sweets cost £3.20. Can we use the same graph for this? And really exploring why the answer to that is no. So the idea that, okay, well, 1 bag costs 80p, but can we buy 1.5 bags or 1.25 bags? Well, we can't. So that graph would not represent 4 bags of sweets costing £3.20. And it's a really nice discussion to have. So we've interleaved quite a few topics there. We've looked at money conversions, for instance, and map scales. But what other topics can you interleave in this review step? And that's one of the great things about review steps. It really gives you an opportunity to revisit material. So this is from the premium resources, and I really like the fact that they bring in the circumference of circles. So of course, circumference being directly proportional to diameter. So again, you might want to pause the video here and think about what you would want to interleave for your class. I was thinking perhaps finding missing quantities in recipes, and maybe pie charts as well. And here's another lovely question from the premium resource. I really like using the idea of examples and non-examples to really check understanding. So of course here, if we look at part A, which graph shows a direct proportion relationship? Well, it's just that first one, but I like exploring with the students the other three. So for instance, this one, some students have the misconception that this is a direct proportion relationship because it's a straight line and it's going upwards. So really highlights the fact that they've misunderstood this idea that if one variable is 0, the other has to be 0 too. And then this second one, some students saying, but it does go through 0. And they've missed the point that actually when X is 0, Y has to be 0 at the same time. And then this last one's lovely, isn't it? That it does go through 0, 0, and there's lots of straight lines there, but actually there's no constant multiplier. And I like to throw in that one as well and just have a discussion whether or not that shows a direct proportion relationship. And then of course you can see there at the bottom that we assess the student understanding even further where they have to draw 2 more graphs that show direct proportion. So the key points from today's snack: use the review steps to interleave different contexts. It's a brilliant opportunity to do so and to do a little bit of revision with your class. Use double number lines and or ratios to support their thinking. And definitely explore different methods with the students. I think they really enjoy that and they can really make sense of the maths, and then think about which ones are more efficient. Use examples and non-examples to check on understanding. And perhaps this block, it moves on to looking at inverse proportion, so perhaps use the same approaches for that. So I hope you've really enjoyed today's snack. I hope there's something that you can take out of it and use in your lesson, and hope that you watch more of our snacks. Thanks very much. Bye.